Namaste, I am Tippeswamy MS, Assistant Professor of Physics, Government First Grade College, Haryana. In this video, I am going to speak on units of stellar distance. It is the subconcept of astrophysics. Friends, let me talk about some part of the introduction about the astrophysics. When you look at the sky during the night, we are able to see the n number of stars. Look at this picture which is released by the NASA. This is taken by the Hubble Space Telescope by one snap, or that means one shoot. It means star field as seen through the Hubble Space Telescope. Students, look at this picture. In this picture, there are the many number of stars having a different in color. See, these are the stars in red in color. See, these are the stars having blue in color. These are the stars in yellow in color. The question is why the stars are in different in color even though they are made by the same material. Let's see what is astrophysics. Astrophysics is the branch of astronomy. As you know, astronomy is the science of heavenly bodies. Astrophysics, which is only connection with the physics of stars, that means laws of physics which are applicable to the stars for the purpose of study the different properties of stars, like that brightness, luminosity, mass, density of the star, velocity, origin, evolutionary stages of the stars, etc. So here from the astrophysics we are going to study the universe, formation of galaxies and the different properties of the stars. So here students, what is galaxy? Galaxy is nothing but a collection of group of stars or a collection of stars. In each galaxy it contains not only stars, nebula and also dust in interstellar space. According to astronomers, there are 10 raised to 11 stars. That means 100 billion stars in each 100 billion stars which are present in each galaxy. And also as well as 100 billion galaxies are there in the universe. According to theoretical physics, there are 20 into 10 raised to 19 stars which are present in the entire universe. By naked eye, we are able to see the 5,000 stars in the sky. So this is our picture of the galaxy. This is the, see students, this is the core of our galaxy. That means, as you know, our galaxy is a spiral type. It means Surulihakar the galaxy. So here the typical number of stars which are, as you said, this is 100 billion. That means 10 raised to 11 stars which are contains in our galaxy. The typical distance of our galaxy, which is this is 1 lakh light year. That means one end of the galaxy to the other end, which is equal to the 100 light year. As you know, it is too much of distance. Same picture, when you look at this picture, this is the central bulge. From this central bulge, this is the present, this is the position of the sun. So in this picture, see, this is the position of the sun. Yes, let me know what is star. Star is nothing but it is a gaseous hot body that generate energy through the nuclear fusion reaction in its core. So initially, although the term is often also applied to the objects that are in the process of becoming the stars, but we also called as the stars. After the evolutionary end stage of the evolutionary stage, to the remains of stars that have died, that means we call as a protostar, that is also called as a stars. Neutron star, it is the end stage of the star, also called as a stars. Black hole, it is also called as a stars. In the astrophysics, we have two methods used to the observation of that stars. Study the properties of the stars. The first method is repeated observations by the different instrument. What is the data which is collected by the observation, that is made, the second method is classification of the data. This is another method to study of the universe. Friends, so here in the astrophysics we are intensely cover these sub-concepts. That means astrophysics is the physics of stars. We have studied the firstly units of stellar distance and different properties of the stars. As you said, different properties: brightness, luminosity, size, mass, density, color, temperature, chemical composition, spectral classification, HR diagram, origin of the star, evolutionary stages of the stars. There are many properties we studied under the astrophysics by using the physics phenomena. Yes, we came our today topic, that is stellar distance. So stellar distance is too large. As a physics people, we are in practical classes, we are measuring the size of the small sphere by the instrument, that is screw gauge. That there are the micrometer instrument screw gauges or millimeter instrument screw gauges. We see the size of the nucleus is also measured. It is about 10 raised to minus 15 meter. It is too small. 10 raised to minus 15 meter, it is too small. This size of the nucleus we measured by the indirect method. Don't have an instrument to measure. This is too small, 10 raised to minus 15 meter, that is size of the nucleus. Suppose if you want to measure, this is one length of this is table, be using some meter scale. Students, if you want to measure the distance between the two cities, we use some kilometer unit, kilometer scale. Likewise, stellar distance is too large. Don't have any instrument to measure this large distance. That's why we are using some most common units used to measure the stellar distance. Those are astronomical unit, light year, and parsec. Astronomical unit, symbolically we represent, that is AU, light year parsec, LU, and parsec is pacing. Astronomical unit is the smallest unit in the stellar distance. How do you consider this astronomical unit? As you know, friends, as you know, Earth revolving, so look at this picture, Earth revolving around the Sun in particular orbit. In winter, what is in this picture, there are 148 million kilometer. In summer, this is 152 million kilometer from the Sun. From this two number, averagely considered as one astronomical unit is 149.6 into 10 raised to 6 kilometer, or 1.496 into 10 raised to 8 meter. What is the meaning of astronomical unit? That means the radius, the mean radius of the Earth's orbit around the Sun is called as a astronomical unit. See, in the stellar distance, it is the smallest unit. It is the Smallest unit. Yes, actually we studied in the large scale astronomical unit. It is the two smallest unit in particularly a stellar distance. Its value is 1.496 into 10 raised to 8 meter. So the second astronomical unit is the light year. Light year is nothing but it is the distance traveled by the light in 1 year, and it is denoted by Ly. So this is one light travels in 1 second into 3 into 10 raised to 8 meter per second. Light year is nothing but this is the velocity of light. This is the velocity of light in 1 second, that is 3 into 10 raised to 8. Actually, we want to measure what is the velocity of light in throughout the year. It is multiplied by 365, that is days, 24 hours, 60 minutes and 60 seconds. After the product of this is, we have got this is one light year is 9.460 into 10 raised to 12 kilometer. This is the value of light year. That means that so look at this small picture in what you on right side. The distance light travels in year is 9.5 trillion kilometer. Trillion is nothing but it is the two larger number. That means it is a 10 raised to 12. That is the number value of the trillion. It is the 1 light year. When this is the light year, when we converted into the astronomical unit, almost about 63,300 astronomical unit. One astronomical unit is 1.496 in 10 raised to 8 meter. It is about 1 light year 63,000 times more than the astronomical unit. This is the light year. Another unit we used to measure the stellar distance. Third unit, that is parsec, stellar parallax and parsec. Parallax is the angle, parsec is the distance. Again we are measuring the indirect method. This is one. Parallax is it is defined as the angle subtended at the star, made at the star by the radius of the Earth's orbit around the Sun. Yes, look at this picture. Here, when you are here at the position B, this is the position B, the tree appears to be in front of this mountain. When you are position A, the tree appears to be in front of this mountain. So here, let's see, this is one position A, this is the position B. As you know, the distance between these two positions, when you focus this trip of the tree by the relative this motion, we get some angle here. That angle we call as a parallax. Yes, from the last slide we learned this is the definition of parallax. Parallax is nothing but it is the angle made at the any star by the mean radius of the Earth's orbit. That is we call as a parallax. So look at this picture. This is the path of the Earth around the Sun. This is the mean radius of the Earth's orbit. We consider two positions. One is E and E dash. When you are here, focus the star. Focus the star. After 6 months, later 6 months, when you come here, again the focus the same star with relative the positions. From the diagram, P is the angle, that means parallax. By the trigonometric ratio, we can able to write A, that means mean radius of the Earth's orbit, that is upon D. Some of the stars, they are far away from us. In those stars, the angle made at those stars by the Earth's orbit in terms of minutes, in terms of second also. That's why this is the angle we converted in terms of seconds. This is P seconds. This is divided by 20, 66, 25. That is equal to A by T. We know that D is the distance of the star from us. Therefore, D is equal to, this is 20, 66, 25 into A divided by this is D. What we call the numerator is taken as the unit of stellar distance, that is parsec. As I said, parsec is the distance, parallax is the angle. Same. Therefore, distance. If the angle made at the star by the Earth's radius, if it is equal to 1 arc second, then D is equal to 1. Thus, parsec is the distance at which the radius of the Earth's orbit subtends an angle of 1 arc second. Therefore, 1 parsec is equal to the 20, 62, 65 into A. Here A is the mean radius of the Earth's orbit. When you keep the value of A, we get this is the answer. That is when converted into the light year. You know the light year is it in terms of trillion. Light travels by 1 year, that is equal to, therefore 1 parsec finally 3.267 light years. Yes, so far we studied what is astrophysics, astronomy, some part of the introduction and stellar distance. Finally, we are going to try to answer these questions from the using of this units of stellar distance. Thank you, friends. Next video I am going to talk on absolute magnitude and apparent magnitude. Thank you very much.